In this mini lecture, I'm going to be talking about the steps for balancing redox reactions using the half reaction method. You probably have the steps for this in your textbook, or you may already have it in your notes. If you don't already have it, you'll just kind of want to take a look at the first part of this video and copy down these notes. I'll quickly talk through the steps. And if you've already got those in your notes and you just want to see an example, you can kind of zip towards the second half of this video to see an example of this being worked out. The steps for balancing the redox reactions. First, you need to split the equation that you're given into two half reactions. And then for each of those half reactions, we need to balance each half. And the first thing you need to balance for are elements other than oxygen and hydrogen. Then you will want to balance for the oxygen, and in order to provide the oxygen to get the balance out, we're going to be using good old H2O. These reactions are all taking place in aqueous solutions. For balancing for the hydrogen, then we'll be adding our H+, that hydrogen ion, to provide the hydrogen to balance it out. Then, because this involves redox and the transfer of electrons, we're going to need to balance each half reaction for the charge, and we'll be adding electrons, individual electrons, to balance for the charge. Once we have our two half reactions balanced, then what we're going to have to do is make sure that they each have the same number of electrons. In order that we may find that the number of electrons is already the same in both. We may have to multiply one or both of those half reactions. And once we have each half reaction balanced, if we multiply one of the coefficients in there to get the electrons to balance out, we're going to have to multiply all the coefficients in that half reaction. Once we have the number of electrons balanced, we will be adding our two half reactions together, and we'll end up canceling the amounts of substances that show up on both sides of the equation. Then at the end, we will double check to make sure that all of our elements are balanced. And again, if you don't already have these steps in your notes somewhere, please go ahead and write these down. Please note also that this is for balancing half reaction or balancing redox reactions when they occur in acidic solutions. If they end up happening in basic solutions, the same process is followed. There's just another step that we have to do after step 4, and that'll be the subject of another video that I have. So let's go ahead and we're going to move over here to the smartboard. And we're going to go ahead and we have an example here of a redox reaction. And our first step is to split that into two half reactions. So in order to do that, we're going to take a look at what is on our reactant side. Say we've got two substances here. We've got our I2, our iodine. And from here on out, I'm going to skip writing down the states of matter. We're just going to focus on the substances themselves. And after the reaction, the only place we see iodine over here is in this IO3 ion. And so that's our first of our half reactions. And our other reaction involves this OCl ion, and that becomes the chloride ion over on the other side. So now we've got our first step done. We've split it into two half reactions. Those are our substances that we're working with. Now, our next step is to go ahead and start balancing. And the very first thing we need to balance for is for elements other than hydrogen and oxygen. So we take a look at this first half reaction and say, well, we've got some iodine, we've got some oxygen, so we're not going to balance for the oxygen first. We'll balance for the iodine. And we see on the left-hand side, we've got two atoms of iodine. So we're going to have to put a coefficient of 2 in front on the right-hand side in order to balance for the iodine. And now that's balanced. If we look at our other half reaction, we have oxygen and chlorine. And so we want to balance for everything other than oxygen and hydrogen. And we look and say, well, we've got one atom of chlorine on each side, and so that's already balanced. We don't need to change anything for that. Now, our next step then is to balance for the oxygen. And you see in our first half reaction, we don't have any oxygen on the left-hand side, but now we've got two of these ions that each contain 3 oxygens. We've got we've got 6 oxygen atoms that we have to come up with. And so our source for that, since this is happening in an aqueous solution, our source will be water molecules. And so in order to get the 6 oxygen atoms that we need, we're going to add 6 water molecules over to the left-hand side of our equation. And now we are balanced for our oxygen in that one. Now in our second half reaction here, we have 1 oxygen over on the left-hand side. So for this one, and I should go back and change over to blue to be consistent, we will add just 1 water molecule here to provide that oxygen atom that we need. In case that color change is bothering anybody, I'll fix that there. Okay, now we're balanced for the oxygen. The third thing we need to balance for is our hydrogen. So in our first half reaction, excuse me, we now have 6 water molecules that contain 2 hydrogens each. We have 12 hydrogen atoms that we have to come up with. And we said the source for those, when we have to bring them into this equation, is going to be our hydrogen ion. And so since we have 12 hydrogens on the left-hand side, we need to come up with 12 hydrogen ions on the right-hand side. And now we're balanced for the hydrogen of that half reaction. In our second half reaction, we have 2 hydrogens on the right-hand side. So we need to add 2 hydrogen ions to our left-hand side to get this to balance. So now we're balanced for all of our elements, and our next step is going to be to balance for our electrons and balance for charge. And so in order to balance for our charge, we're going to add the electrons in. Now this is the part that starts to get a little bit tricky for students. And so this is the one that you really want to be careful and make sure that you're accounting for all of your charges. Now, in our first half reaction up here, I'm going to write these numbers in temporarily, and then I'll go ahead and erase them when I'm done. But when I take a look here, I say, well, our water molecules here, our 6 water molecules up here, they're neutral. They don't provide any charge. So as far as the charge contribution here, that's 0. The iodine molecule that we have here, that's also neutral. That produces 0. So our total charge over here of what's being contributed on the left-hand side is 0. It's neutral. After this half reaction, we have 2 of these IO3 ions here that each contain a single charge. This is really contributing a total of 2 negative charges to our equation on this right-hand side. And we've got 12 positive hydrogen ions, so they're contributing a total of plus 12. Well, when we add this negative 2 to the plus 12, we find that we have a total of 10 positive charges on the right-hand side. So on the left-hand side, we have 0 charge. On the right-hand side right now, we've got 10 positive charges, and we're trying to get this to balance. So we say, well, there's a difference of 10 here. And so we have to add in 10 electrons, and this is where it gets tricky. Which side do you add them to? Well, please note that electrons are negatively charged. If we add 10 electrons to the left-hand side, that's going to have a total charge of negative 10. And we'll have negative 10 on the left, and we'll have positive 10 on the right, and that's not balanced at all. So the only way to get this to balance is we have to add the electrons to the side that's more positive. And obviously here that right-hand side is more positive. So we'll end up adding those 10 electrons to this other side. Now I'm going to erase that to get out of the way. But I will add 10 electrons to the right-hand side. That'll add in 10 negative charges, and then I will have a net of 0 charge on the right-hand side to balance out my 0 charge that's on the left-hand side. And now when I'm done with that step, I'm just going to erase this thing. Because when you're doing these balancing reactions with a half reaction method, things get a little bit cluttered up here. So I'll end up erasing those. Now, we have a similar thing with our second half reaction. This time, we have 2 positive charges coming from the hydrogen, plus we have a negative 1 charge coming from our OCl minus ion. And so when we add our +2 with our -1, we get a +1 for the total charge on the left-hand side of our equation. Our right-hand side, we've got a -1 chloride ion plus a neutral water molecule for a total of -1. That's not balanced. So this case, we take a look, again, we take a look at the side that's more positive. This left-hand side in this case is more positive, and it's more positive by 2, because a +1 is 2 more than a -1. And so what we'll have to do here is add in 2 negative electrons to get that to balance for charge. And that will make us have a -1 charge on the left and a -1 charge on the right, and we'll be balanced for charge. Now, at this point, we're balanced for our elements and we're balanced for our charge. Our next step is to look at our two equations. Soon we're going to be combining these two, but before we combine them, we want to make sure they have the same number of electrons in each equation. Now, one thing that you should double check at this point, in your two half reactions, it has to be this way, that one of the half reactions will have the electrons on the left side and the other one has to have them on the right hand side. If at this point, if you find that you've got the electrons on they're both half reactions have the electrons on the same side of the equation, you've made a mistake. You got to go back and figure out what went wrong. But in this case, we've got two electrons. Our first half reaction, we got our 10 electrons on the right hand side. Our second half reaction, we have our 2 electrons on the left hand side. So we're in good shape there. But we have 10 in the first one and only 2 in the second one. So what we're going to do here is we're going to take all of this equation, all of this second equation down here, and we're going to multiply it by 5. That way, if we multiply all our coefficients by 5, what we're going to find is we will then have 10 electrons in the second equation. So once we multiply all our coefficients by 5, we'll have 10H plus 5 OCl minus plus 10 electrons, and then on the right hand side of this equation we'll have 5 chloride ions plus 5 water molecules. And on your paper, you'll probably be leaving those on your paper and not erasing them, but on the smartboard I can easily go ahead and erase this. Okay, another thing I can do on the smartboard that, I can do that. Another thing I can do on my smartboard is move things around a little bit easier. So I want to move that one up. Okay, now our next step here, is going to be to add these two equations together. Now the instructions say to add them together and then cancel out things when you're done. I prefer to go ahead and cancel things out ahead of time if I can, because it just makes it a little bit neater in the process. So for instance, we look at this and right off the bat we said we've set it up this way purposely so that we have, if we look at how things look in our equation before and after here, we've got 10 electrons before, 10 electrons after. They're kind of like spectator ions that we've talked about before. They kind of drop out of the equation. We also could subtract, now we take a look, we've got 10 hydrogen ions before and 12 after. We could subtract 10 hydrogen ions from each side here. You could say, well, let's just subtract 10 hydrogen ions from here, and that's going to completely go away. And if we subtract 10 hydrogen ions up here, what are we going to have left over? Well, we're going to have 2 left over. So we subtract those from that side, and then we're going to have 2 hydrogen ions after that point. Water molecules. We could subtract 5 water molecules from both sides. 5 will go away there, and then we'll have just 1 up here. And is there anything that shows up on both sides? No, that's pretty much it. So now we've canceled out what shows up on both sides, and we could rewrite the equation to say H2O plus I2 plus 5 OCl minus yields 2 IO3 minus plus 2H plus 5 Cl minus. And we can double check and make sure that we've got the right amounts of everything. We've got 2 hydrogen atoms before and after. We've got 2 iodines before and after. We've got oxygen. We've got 1 from the water and 5 more from the OCl minus. So we've got 6 oxygen atoms before. We've got 6 oxygen atoms after. We've got 5 chlorines before, 5 chlorines after. And we can also do the same thing with for the charge and find out that we've got 5 negative charges before and 5 negative charges after. And so everything's balanced, and that's a good final check on this. And again, this is for an acidic solution. If this had, you could tell it's an acidic solution because you come down here and say, well, we've got some hydrogen ion there that's being produced here. That would make it acidic. If this is a basic solution, there's another step we've got to do, and that'll be the topic of another video.